This video looks at the calculations of concentrations of solutions, and the main formula is that molarity equals moles of solute over volume of solution. You may also need to use the formula covered previously, which is that moles equals mass over molecular mass. Okay, and noting that this moles here would be the same as that moles there. So if you're not given all the information, you may need to use both formulas. So let's look at the question. It says 100 grams of potassium carbonate is dissolved in water to give 500 ml of solution. What will the molarity of the solution be? So we write out the information we've got. We've got that the mass of K2CO3 is 100 grams. We've got the volume of solution, is 500 milliliters. What else do we know? We know it's we know we want to find the molarity. So now we have to work out how we're going to do that. To work out the molarity, I need the moles of solute, which I don't have, and I need the volume of solution, so I do have that. So from there, I know that I need to work out the number of moles of K2CO3. So this brings me to this second formula, and I go, okay, well I need to know the number of moles. Have I got the mass? Yes, I've got the mass, but I need the molecular mass. So that's where I'm going to start. So for molecular mass, I need to know the atomic mass of each atom. So for K2CO3, look at my periodic table. Potassium is 39.098 grams per mole. Carbon is 12.011 grams per mole. And oxygen is 15.999 grams per mole. So my molecular mass is the sum of atomic masses. So pen doesn't want to write. We've got 2 atoms of potassium, 1 of carbon plus 3 of oxygen. So that's going to be 2 times 39.098 grams per mole plus 1 times 12.011 grams per mole plus 3 times 15.999 grams per mole. Plug that in your calculator and you get 138.204 grams per mole. I can now use my second formula, which was moles equals mass over molecular mass. So that's 100 grams over 138.204 grams per mole. That gram cancels with that. Plug into my calculator and I get 0.724 moles. Okay, now I'm going to move into the formula. I should be working down my page, but I've run out of room. Molarity equals moles of solute over volume of solution. Now my volume was 500 milliliters, so in liters that's 0.5 liters. So moles of solute was 0.724 moles over 0.5 L. Plug that into your calculator you get 1.447 moles per litre. So finish off with a statement, therefore the molarity of the solution would be 1.447 moles per litre. And I'll highlight my answer so it stands out. Okay, just another point, as I just said, I did go from here up here. You would work down your page, not across, but I did run out of room. Let's move on to another one. What weight of sodium chloride? So what weight sodium chloride would you have to dissolve in 250 ml of water to prepare a 0.5 molar solution? So start by writing out the information you've got. The molarity equals 0.5 m, which is the same as 0.5 moles per litre. The volume is 250 ml, and this time I might just change that to litres right now. Divide by 1,000 and then 0.25 litres. So the formula is molarity equals moles of solute over volume of solution. Now I have the molarity and I have the volume and I need the moles of solute. So rearrange that. I get moles of solute equals molarity times volume of solution. So all I've done there is to get this moles of solute on its own, it's being divided by the volume of solution, so I times both sides by it. Plug in the information I've got. Molarity is 0.5 moles per litre times by 0.25 litres. Plug that into your calculator and you get 0.125 moles. That litre cancels out with that one. So I continue on, remembering I'm trying to find mass. That's what I need to know. So that's when I use my other formula, which is moles equals mass over molecular mass. Remembering that I am trying to find mass. I have moles, but I don't have molecular mass, so that's what I'm moving on to. So calculating the molecular mass. So looking at my periodic table, the atomic mass of sodium is 22.990 grams per mole. Of chlorine is 35.453 grams per mole. So molecular mass is the sum of the atomic masses. I'm not going to write that out because you're probably sick of hearing my voice. So that's just going to be one sodium atom plus one chlorine atom. So that's 22.990 grams per mole plus 35.453 grams per mole. Plug that into your calculator and you get 58.443 grams per mole. Okay, so now I have my molecular mass or my molar mass here, and I have my moles of my solute there. So I move into the next formula, and I know I should be working down, but I'm going to run out of room, so I'll write it here. Is moles equals mass over molecular mass. So rearranging it, mass is going to equal the number of moles times by my molecular mass. If you don't understand that, have a look at the equations module. So that's 0.125 moles times 58.443 grams per mole. plug that into your calculator and you get 7.31 grams, remembering that that mole cancels with what's on there. Finish with a therefore statement, which is NaCl would weigh 7.31 grams.